All right, go ahead and send it.
All right, man. So let's start with the formula that they use for curvature, right? 8 inches per mile squared. If we were to graph that out, as they so commonly point out, that is not a sphere; it is a parabola. Here we go, which is
Right.
the graph of x squared, which means that that little line approaches infinity but never quite gets there, which is not a linear function, right? So when you're saying, "Hey, we see in perfect 3D Euclidean orthographic space, and I can project this distance out to infinity, and that would mean that it's this many miles," right? No, incorrect. Incorrect. Because if they do that with what they already have with the 69 miles per degree, then you actually have to get like some math together, right? You have to say, well, 69 miles per degree with 90 degrees of separation between, say, north and the equator. Then you're left with something that is not 3959. You're left with something a little shy of 6,200 miles. So then is the radius of Earth 6,200 miles or is it 3959? It's like, because you can't have both of those things. And then also the argument that, oh, our distance scales linearly. Because a linear scaling distance would decree that that 69, that 6,200 miles would then be the radius. But that's not the radius because we don't see that way. We see logarithmically, which is the inverse of parabolically, right? Which is just like if you were to approach infinity towards the end of your vision, when things compress into the horizon, they approach infinity. The best way to mathematically describe that is logarithmically, certainly not linearly. And using that principle, plus, if you say use the modeling software, like if you use say a unit circle and use a radius of say hypotenuse of 3959, and you put that circle around the observer and you mathematically model that observer approaching the center, which is what I did with the math over here, then you can actually get all of these relationships from the very easy math of just using, let's see, a sine and cosine to approximate the length and the height, or in this case would be the distance and the ground position of a star. You can use those two functions to repeatedly approximate that distance as you approach the equator, and you can model out the exact equivalent principle that they'd used, but you can see that it only models it out at a certain degree. So if you have a logarithmic function and you want to lie and say it's linear, how you would do that is restrict someone's viewing and using of that to a certain degree. So if we look at this,
You pulling up the image of the celestial dome with the tailored angles to 45?
oh, that's not,
I think you lagged out a little bit, brother.
yeah, hold on.
Why does it say I'm new here next to your name?
Because I got banned recently, of course.
Well,
Oh,
means you're doing something right.
right. So if we lose this little sphere and we say that mimics like, an angle. Oh, wait, I got more.
Yes, and the
Is that
yeah, the other
nanometer?
nautical
Nautical mile.
miles,
Nautical miles. Okay.
nautical
Sorry.
meters.
Nautical meters.
I just got more of them. Hold
Apparent altitude must be dropping, not all intersecting at the same point for the celestial. Celestial is not in a fixed physical position.
Right. So that's a little bit past what we're at, but look.
Sorry.
No, 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 I put it in there because that's where we're going next. So this is what I'm talking about, right? Divided between this, and then what they do is they restrict your usage of this logarithmic function to the segment where it is linear. So
Hmm.
that if you use, say, above 20 degrees, which is where they let you, all the way to say 70 degrees, which is where they let you, then you'd be hard pressed to mathematically differentiate those two things. However, if you use it past there, where it does approach infinity, and that is the logarithmic curve part of the function, then yes, that would prescribe interesting as results. They do have tremendous correction tables that will allow you to do this if you want to use what they call, see if I can remember this off the top of my head. I think standing longitude corrections, which are huge, huge corrections. I think I have them in the back of the book here. Like then you can use things past there, but it's ridiculous because all they do is mathematically reflect your linear function to a curved one, because the difference between linear and curved in Excel, guys, is just a difference of 90 radians. You just flip it one way or the other. It's like another translation that's mathematically easy, right? So the same way you can project coordinates of the same thing back and forth, you can turn sphericity to linearity in like just 90 radians. Off you go. Anyway, back to the logarithmic expression of our view, right? We started with they express curvature, 8 inches per mile squared. That's a parabolic function. That is not linear. That is because if you lose these angles and you use their formula, then you'd have more of a radius towards the Earth than is prescribed. Than we have. So the only way it makes sense is if we use our logarithmic expression of these angles all the way to the equator, and in that way, you can mathematically model 69 miles per degree, not linearly, right? Because that means the ones off to your distance are less, the ones behind you are less. They're not all linear. But again, if you use their linear function and you go right under its zenith, or you go where it's on the horizon, it does not describe a linear relationship. It will not move 69 miles per degree when it's right on your horizon. You'd have to approach several miles for it to actually have that linear relationship. You'd have to have it at least, say, 20 degrees. Oh my God, look at that, 20
20
degrees
degrees.
above. Then it would
Wow.
have a linear relationship and have that all the way to 45 to 70 degrees, and then it would stop being linear again.
And then
So
go
what
into infinity. Yeah.
Yep. So they've literally locked you to do that at that stage and said you can use those angles from our logarithmic Koff linear function, and then you can use that to detect degrees. So that's because, ladies and gentlemen, they need you to think linear distance scales infinitely, because light speed with no attenuation and hyperbolic, like all that ridiculous hyperspace shit, dude. The galaxies and stars and all that shit has to be, well, because we can see light forever. That's how we know that. We know that we can see light forever. If you ask them why they think that, this is why. So we got to take that away. I'd like to understand where that comes from. The true mathematical description is logarithmic, and they've been giving it to us parrotingly the whole time without even realizing it, guys. It's not a circle, it's a parabola. How right you are, globe friends. How right you are. Let's go ahead and take that back. Use the inverse expression to describe our vision, and then we'll use that to construct the celestial sphere and actually correctly model every fucking star from every position on Earth. What do you guys think?
These correction tables, right?
Sold.
When do they start in terms of like
20 degrees to 70 degrees.
right. I'm saying after that, right? So it's like 71 degrees, 72, and it starts the correction tables up and onward, and then like
Yep.
19, 18, 17.
Yep.
Oh wow.
Right? It's like, yeah, it's exactly that.
Okay.
Yep, they're
So
just
the other part,
they provide you nice tables to bring you right back to the globe.
Right.
I just think it's funny that they haven't put this together. Like the Globers who have been yelling that it's a parabola at us. I can't wait to see their faces, but I'm like, it sure is, boys. Let me show you how that matters.
I think we should set up a debate between Shane and McToon, where Shane goes over this and see what McToon has to say.
I think it's better served against an unwilling nincompoop on modern day debate. What do you think? Like, hey, you want to talk about the flat Earth? Sure. And then I bring out this, and they're like, well, I did like, I don't
My
actually. I
fucking brain, bro.
don't know what they'd say, to be honest. Dude, this last part, that one that you pointed out, the apparent altitude, what that is, right? You know how they say that, like, oh, you can't have a different angle for polarities because it doesn't converge. It turns out, guys, if you don't let it go below 30 degrees or 20 degrees, which is what they dictate for the linear function, if I apply that same rule to mine, well, then they do all converge. It's specifically right at 30 degrees because I can't go below that, right? Can't have it apply to you and not to me. So a double stack of fuck off.
The best
Wow.
kind.
Alan, you need to order NAC, bro.
Who's that?
Like right now. I'll buy it for you, dude.
I don't know what that is.
It'll
Oh,
help.
yeah, I don't give a shit.
But you do.
Nah.
But you